Imagine the universe as a giant game. For a long time, we thought that we knew all the rules. But about 100 years ago, we realized that when the players get small enough, the rule book changes entirely. This is the divide between mechanical, classical physics, and quantum physics. First one, the world of certainty. Mechanical physics is the science of the world you see. It describes everything from a falling apple to the orbit of the moon. It is governed by determinism. In this world, if you know the starting position and the force applied to an object, you can predict exactly where it will go. This is summarized by Newton's second law, FEMA. Force equals mass times acceleration. In mechanical physics, energy is continuous. Imagine a ramp. You can stand at any height on that ramp. You can move a tiny bit higher or lower without any restrictions. Everything is predictable, solid, and makes common sense. Second one, the world of probability. When we zoom in to the size of atoms, the ramp disappears and is replaced by a ladder. This is where quantum physics begins. The word quantum itself means packet. In the quantum world, energy is not continuous. It is quantized. An electron cannot be anywhere. It can only exist in specific energy levels. To move up, it must absorb a specific packet of energy, described by Max Planck's famous formula, E=hf. It means that energy equals Planck's constant times frequency. Third one is the core differences. To understand why these two worlds clash, we need to look at three scientific principles. A, wave-particle duality. For mechanical physics, a baseball is a particle. A ripple in a pond is a wave. They never swap roles. For quantum physics, everything, light, electrons, even atoms, behaves like both a particle and a wave. This is described by the wave function, denoted by the Greek letter psi. Until we look at it, a particle spreads out like a wave of possibilities. B, determinism versus probability. Probability, for mechanical physics, if I kick a ball, it will be at point B in 3 seconds with 100% certainty. In quantum physics, we can only say there is a 70% chance the electron is at point B. We use the Schrödinger equation to calculate these odds. In this equation, doesn't tell us where the particle is, it tells us how the probability wave changes over time. See the active observation? For mechanical physics, you can watch a car drive by and your eyes don't change the car's path. In quantum physics, small particles are so sensitive that the act of measuring them changes their state. This leads to Heisenberg's uncertainty principle, which states that you cannot know both the exact position and the exact momentum of a particle at the same time. Fourth one is that why the difference matters. Mechanical physics is perfect for building bridges, flying planes, and understanding gravity. It is the physics of the large. Quantum physics is the reason your smartphone works, why lasers exist, and how MRI machines scan your body. It reveals that at the foundation of our solid world, there is a buzzing, vibrating field of energy governed by chance and waves. In summary, while mechanical physics is like a movie, every frame follows the one before it in a logical, visible sequence. Quantum physics is like a video game that hasn't been rendered yet. The computer knows all the possibilities, but the image only clicks into place when you turn the camera toward it. One is the physics of what we see, the other is the physics of the invisible foundation that makes everything else possible. Thanks for watching this video. If you'd like to see more topics, you could like the video and subscribe